Here's how we can solve right-angled triangles using the vertically and crosswise sutra of Vedic mathematics. The 3, 4, 5 triangle is well known. It's a right-angled triangle with a base of 3, a height of 4 and a hypotenuse of 5, and it has an angle very close to 53 degrees here. And we write it like this: the angle 53 degrees, then the base, height and hypotenuse like that. Now, how can we use this triangle to solve another triangle? Suppose, for example, we've got this triangle here, which has got a height h and a hypotenuse 2 and an angle of 64 degrees. Well, note first of all that 64 is 11 more than 53. So we're going to put 11 here. And then we're going to put another triple triangle here with sides 5, 1 and 5. And that is determined by the fact that the product of these numbers here has to be around 57. And so we put down 5, and the last number's the same, and the middle number's always 1. So now, how do we use those numbers to get h? Well, h is going to be 2 times, where 2 is the hypotenuse, which is given, 2 times a fraction, and the numerator of the fraction is given by cross-multiplying here and adding. So that means 4 times 5 plus 3 times 1, that's there. And the denominator of the fraction is given by this vertical product, 5 times 5. So that's going to be quite easy to work out. We have 20 plus 3 is 23 on the top and 25 underneath. And if we double twice to get 100 on the bottom, then it's 0.92, which when we double we get 1.84. So that's it, and I'm going to show you another example just to make it clear. This time we're going to use the 4, 3, 5 triangle, like this. So it's got an angle of 37 degrees, and it's described like this. And we're going to find a side of this triangle. So the first thing we look at is the difference between those angles, which is 7 degrees. And we want to determine this number here, and the product has to be as close as possible to 57, so that's going to be 8. So we have 8, 1, 8. We now apply that formula. So h is 2 times, 2 again is the hypotenuse, and then we have a fraction where the top is from this crosswise product here, and the bottom is from the vertical product there. So it's going to be 3 times 8 plus 4 times 1, which is there, over 5 times 8. And so we work that out. 24 and 4 is 28 over 40. We cancel by 4, 7 over 10. So that's 0.7 times 2, which is 1.4. Now we can actually reverse this process to get an angle. So the next example is going to be, given h is 1.4, to find out what the angle is. So it's a reverse of this. So that's our base triangle again, 4, 3, 5. And this is the triangle we want to solve. This time we've got a height of 1.4 and an angle A. And again, we write out the triples like this, 4, 3, 5 dash 1.42. Okay? And then the pattern is this, which we can derive from the previous example. So we work out A. It's going to be the base angle, 37. This one here, that's 37. Plus this fraction times 57. That's the same 57 as we had earlier. So the pattern is similar because we cross-multiply again here, and we subtract this time. For angles we subtract. 5 times 1.4 minus 3 times 2 is on the top there. And the dashed line, 4 times 2 is 8, is underneath. So it's simply a matter of finding this fraction of 57. And this fraction always turns out to be a small fraction. If you work out the numerator, you've got 7 take away 6, which is 1. So we end up with 1 over 8 times 57. And 8 into 57 is 7. So we add 7 to 37 and get the 44 degrees, which is what we had before. So we can solve, in fact, all right-angled triangles in a similar way. And we can use any known triple as a base. We don't have to use just 3, 4, 5 or 4, 3, 5, although we could just use those two triples if we wanted, which are these two here. and there are other triples as well available if you want to use those.